Thank you, everybody. Welcome to my presentation. I'm going to be talking about large projects, specifically long-term projects, and I'm doing it from a sort of freelance perspective. So I'll get into this. And I work with SIP, Systems Integration Plus. We're located in North Scottsdale. We have 17 employees. There's the front of our building. And we're a VAR Plus partner with NI. I'm a certified LabVIEW developer, and I've been using LabVIEW for quite a long time. And we have quite a few very nice clients we work with, including on semiconductor. So, yeah. Here's a list of some of our clients, including in the corner over there. But yeah, we've done quite a lot of work with military, aerospace, and commercial industrial clients. And within the company, I actually work with specific clients to provide solution systems for them. So hardware and software combined to solve a problem they're having. The other things we do are electronic packaging systems that involves chassis, enclosures, complete off-the-shelf systems if you're not familiar with COTS, full system, subsystem, and all the way down to electronics design, power supplies and backplanes and things like that. So we really can take your requirements and turn them into a final product that meets your needs. And you can see we have some very interesting and intricate solutions for problems that are not easily solved in some cases. I am Jason. I've been with SIP since January of 2000, so quite a long time now. I have worked with many clients to develop them LabVIEW-based hardware and software solutions. I also do web design to create back-end interfaces on the internet, cloud solutions, things like that. I've been programming since I was this high. I actually used to play in a box full of punch cards, and apparently when you disorganize them, they don't like that. But I didn't know, so well. I've also been a graphic designer for 21 years, which is actually great for LabVIEW because LabVIEW is so visual, it really appeals to me. That's one of the things I love about it, is I can look at the front panel and see what it's doing, flip it over, and see the icons and all that good wiring. And this is actually an example of one of the things I've done for my clients, which involves both graphic design and system design, which is creating clear descriptions of what we intend to do for the client. This is actually a fairly complex system, but breaking it down with simple line drawings, color, and organization, you can actually simplify incredibly complex things into things that you can digest quickly. And that's a large part of what I try to do, is to take complexity and make it less complex. Yes?
Out of curiosity, what's your favorite tool or tools to do this kind of diagram?
I knew you were going to ask that. Somebody at least. This is actually done in Illustrator. I love the Adobe tool suite. Photoshop and Illustrator and all of that. InDesign is great. Illustrator is wonderful because you can make a image that is the size of a billboard in pixels, and you can do anything you want and scale it to any size you want without losing quality. Photoshop doesn't do that. It gets all destroyed when you make it different sizes.
So it's scalable vector instead of...
Scalable vector, yeah. Which also is SVG if you want to output it. So yeah. So achieving success with long-term projects. I have a quote here from Winston Churchill. It may at first seem like a bit much to say victory, at all costs, in spite of all hardship. Without victory, there's no survival. But when I'm working with clients, if I have this attitude, they are suddenly a bit happier about what we're doing, because the reality is that, as Mythbusters tells us, failure is always an option. But what clients don't want to hear is failure is always an option. Clients want to hear, we're going to make this work and it's going to be successful. And so taking this sort of really hardline attitude towards success is something that is very beneficial for me. It's, we're going to have problems, we're going to defeat them. We're going to be successful in what we're doing, and we will overcome our problems. So, I move on to, you're the expert. Everybody here is a CLD or CLA for the most part. The customer needs you to help them be successful. They wouldn't have brought you in to work on this project if they didn't need somebody with your skills and capabilities. At the end of the day, your success is measured by their success. They need to make money to keep you working for them, so you need to help them do that. And that's, with the other quote and with this, is really how I approach projects. So I'm going to discuss understanding success and communicating with your team. We talked a little bit about that with like code review and things like that. But how you plan for success. Then I'm going to talk about flexible, expandable design and specifics involved in that. And then advanced features, avoiding pitfalls, and testing and verification. And you'll see at the bottom here, how many of you have seen the blue thing right here before in the past? Everybody? Okay, great. I'm going to talk about these things, requirements gathering, all of those. And please ask me any questions you want to clarify anything I'm talking about during these lines. And in a lot of ways, what I'm going to talk about is the way we do it, the way I do it. And I've had success, and I'm going to specifically talk about the project I did with On. And I'm still doing, actually. So to be successful, understand your project, develop a strategy, create a plan that will lead to a successful outcome based on that strategy, and then track your progress. Keeps you from getting off in the weeds. You know, I go into a review with a client, and they say, "Oh, this is wonderful, but I wish it had a skateboard also." If you go off and chase that, you've deviated from that path you set, and now all of your timing and all your planning can be invalidated in some degrees by that happening. And I love the quote from Abrams, "When eating an elephant, take one bite at a time." Because when I sit down in a project and they say, "We are going to make a system to test all the inputs and outputs to this rocket. We're going to have 4,000 inputs and outputs." I go, "Oh my God, my head's going to explode. How could I possibly do this?" Well, it's not 4,000, it's chunks of things. They don't all do the same thing. So let's break that down into the components that make that system work. And suddenly we have a MUX that handles half of this, and a system that handles this part over here. And now our super complex project is a series of small projects that chain together. And that makes it so much easier to understand, and then so much easier to plan. So for the On Semiconductor system we created, that's a picture of it on the right there. It looks mighty complex when you first stare at it. There's a whole bunch of components, a big pixie, a bunch of signal conditioning, and a duct tester. We wanted to test AC and DC parametrics, and we have adopted a very nice system, and we realized from the results of this, 3 times the cost savings and 10 times faster. And this is from when we worked with Ray. That was several years ago. This system has gotten more complex and does more now than it did then, and it's had even more significant cost and efficiency savings for the system, for the company. So On is very happy, and I talked to my contact here about coming back and doing even more work with them in the near future. So it's an ongoing project too. So when I talk about understanding a project, the most important thing is, what is success? How are we going to be successful with this project? With the tester, we had to come in under a certain budget, and we had to provide quality and speed on the system. And they didn't really say it has to be 3 times faster or 10 times faster. But in some cases, what they were doing was going up to a manual box and twisting knobs to come up with the tests. And some of those tests could take days. Now we do those tests in milliseconds. So it's a huge difference, and it's really doing nice things. Then you must figure out what the requirements are, what the specifications and standards are, what the desired but not required features are. Sometimes they'll say, "Oh, we also wanted to do this," and kind of putting it through a filter that says, "Do you really need that?" If you can take out some of those wants from your initial system design, you can simplify it further, and then you have less chunks to break up. Who are your end users? How are you going to make the system work in a way that makes sense for them? And then testing and security and safety both are very important. And I'll hit on some of that later.
I just want to ask everybody, how many people had troubles with that first one?
Go back.
The requirements. Does everybody have troubles with that?
It depends on the environment.
I tell that.
If you're in an engineering environment where everything is something extra, then you just kind of have to roll with it.
I know.
Make
I
things
was
a little
just
more-
curious if I'm the only one that finds that the worst thing to do.
And there are groups, I'll toss up
It's a
RF
movie-
designers.
It's
I'll
a
toss up
movie
RF
target.
designers. They don't get software requirements, and you really have to beat them out of it.
Oh, yeah.
Gee, I want something that does this. You've got a week.
Yeah, over here.
For our practical experience in our highly regulated environment, I have never seen a system released that was not, the spec document was not already a Rev C.
Oh, sure.
Yeah,
It should be.
We're
And you're
forced,
using
we're
Rev
forced
A.
by regulation we're forced by regulation to release it as Rev A because we're forced to follow a process that says when we get the customer's requirements, we have to release it as a drawing. And I swear to God, every system I've ever seen is at Rev C or the requirements document before it actually gets qualified and put in the field for the first time.
That's a good sign that somebody actually read
You
it.
will get, in my experience, you will be on your third version of requirements before you qualify.
Yeah.
If you keep track of that kind of thing.
Yeah, I actually, when I ask the question of clients, I honestly ask them, what is success? You brought me here to do something, what will you consider a successful project? And at the end of the entire project, if I can go back and say, hey, you said success was this, it totally does that. You're happy, right? And how do they say, no, I'm not happy? Because, yeah, it does that. And that's really the key, is we want to make our clients happy at the end of the
But
day.
jump right back on his bandwagon. They don't know what that is.
Yeah, almost nobody
Frequently, they don't
knows
know what
what
that
success
is.
is. And that's actually a great question to
It's
ask
very
them to get them
difficult, yeah.
thinking about that.
I've been trying to convince the team that I'm working with, the hardware design team, that we need to set up a requirements document just as strict for the software I'm going to try and write as it is for the hardware they design.
Yeah.
They don't want to do that. We don't need to write it up, you're just going to write software.
Exactly. Well, there's companies out there that are killing themselves for this. Bias has to write up there on the list.
Okay.
Jimmy, get out there.
Yeah, so speaking about the requirements gathering, so this is one of the chips that we test with the system. It's a real chip that we really do test with OnPoint. Here, when I was writing the software, I came up with a visual person. I wanted to have some visual indication of what these tests are really doing. In part, so new users who haven't used the system and aren't terribly familiar with parametric testing can kind of see what a TWL test is. Well, okay, with okay, what does this do? And you can see the AD points, which are usually the measurement points. You're measuring things or time between these points. So I created graphics for all of those. And then I created design notes. This is from 2007. This is the original design notes I came out of our first meeting with. And you can see it has a workflow. It also has an AC and DC call out what is required. Right underneath the heading, what is required? What is it supposed to do? And I took that and we went back and said, okay, based on this, we need these kinds of hardware, we need these kinds of software, and we needed to do that. So this is what we actually came up with as a hardware solution for it. It's pretty complex. It's got a modem in it, so it gives you an idea how old this is. It's got a 2 gigahertz, 40 gig hard drive on it, an 18-slot Pixie. It goes down to Excel 2003. Yeah. It's got temperature control. It's got some GPIB devices on it. It's got Flex DMM, RF signal analyzer, and a unit under test, which is a chip, which is pretty much everything in the system since it's a semiconductor. And you can see the data flow and the signal flow between everything as well. So it's a good diagram. It kind of gave us a flow idea of what we're going to do. It's not the most organized thing, but it does do the trick. And you can see over here on the right what that kind of looks like when you put it in the rack. So some of the products we use, and when you're doing testing, sort of a look of what the user interface looks like. And I'll go back to the user interface later. But the initial idea was we're going to have a very long series of tests, and we want to show what's happening to the user when they're running the tests, and give them progress, and then give them the ability to load tests and make it simple. You know, big red abort button, big white button, go back to the main menu. Keep it simple, even though it's complex. Don't make it look complex to the user. Users don't like complexity. Users want to push a button and it starts running and everything tells you it's great unless it's not great. Strategy. Okay. An effective development strategy. Build and fix. Who uses build and fix here? Sometimes. I know, right? And you know, there's better strategies than build and fix, but find one. I don't care what it is. Find one, talk to your customer about it, talk to your team members about it, and get some agreement on that. Are we going to do a hybrid? Are we going to do, extreme? Are we going to do agile? Anything like that's fine. But whatever system you're using, make sure everybody's on the same page about that system, so they don't get confused as to what are you doing next, or where are you at in the process. And then document your plan. Break it into blocks and section items. So you can see this is the diagram on the right that I showed before. And this is my set of things that I'm going to do to make this project work. So test configurator, test sequencer, test execution and data processing. That's really the flow of data through any test system, right? And what the kind of things we need to do in it. And then based on this, so I've broken it down from this large thing to a bunch of little points. And this becomes my requirements document. Well, it's only one page, but it has all the major things I need. And I can actually look at these and say, well, save data to single, multiple text files. Well, I can kind of guess how long it's going to take. I've done that before. So I can write down, 5 hours next to that. And you can do that for all of these items, and suddenly have a reasonable guess of how long it's going to take to build the system. And all my clients require an estimate before I start working, sadly, because I really love some clients to come to me with, take however much money you want, but we seem to like that. So it gives you workflow determination, time estimates. It also gives you milestones. And so back to that process before we talked about is, where are we at currently? Customers love to know where you're at. Oh, I'm 40% done with your project. It's so much better than, I'll be done before the deadline. So if you can set up milestones, now you have several deadlines. You can also get them to pay you at several points in the project too, which is great too. My boss, who's Gunner over here in the corner, he likes that when we get paid.
Do you use the requirements manager, the national tools for tracking your metrics?
I love that tool, and I don't use it. I will probably use it in future projects. I don't think Requirements Gateway existed when I started this project. So I had to use my own tools. That spreadsheet
Yeah.
really works pretty well. It's got columns that add themselves up, and you can put in how many hours you've worked, how many hours you're supposed to be working on it. Excel now will make a cool graph on the corner, like you're 48% done. I love that. Communicating with your team, like PT, for those who can't do that. Make sure everybody on your team clearly understands the development strategy. It's phase-based waterfall, so they know where you are and where you need to be. Make sure everyone understands the plan, the components, and their roles. What are you supposed to be doing right now? Sometimes people get confused in a team, and they start doing random stuff that's not what they're supposed to be doing. If everybody knows where they're at and where they should be next, they can be on track, and when you ask them what they're doing, they can give you intelligent answers that are cogent, talk about what they're actually supposed to be doing. And that allows you to track your progress. But the most important thing here is, like the A team, everybody on the team contributes what they're best at. You have experts in specific things on your team, hopefully. They all should be talking about what they're good at and how they can make this project better. We were talking about code reviews. A project review, looking at that diagram of how the wires go together, or how the plan to chunk the system up. People can come back and say, don't do it this way, do it this way. Or, I know RF, why are you doing this way? It's going to cause all kinds of problems. And if you get that feedback up front, before you started coding, you can make your system that much better and make it faster and for less money too. And you don't buy the wrong hardware, which is always frustrating. So in the on-point system, let me get into more specifics here instead of we generate tests in an iterative process. There's a lot of loops that generate code, essentially. The code is states in my state machine. All of my states are very small. Each state is something like talk to the GPIV and send it this command, or open this device for talking to it. And what that does is when I go through my test list, which is very general, it's just do these kind of things and do them a bunch. It creates a test recipe, which that test recipe gets turned into test instructions. So this is really my recipe over here. And test instructions are, set the generator, set the mux to a specific configuration, and then you do the test. What that allows is very fine-grained control. I knew from the beginning of this project, we're going to be adding tests to this, and I have no idea what they're going to be, and I have no idea what they're going to do. So I need to chunk up my hardware into abstract accesses that I can do at any point, and then change the way they work, or add new hardware, because we're going to be adding new hardware. We added a lot of new stuff to this. And by doing that, it's giving me all the flexibility I needed. The client tells me every so often how happy they are and that it's so easy to expand stuff. They bring me in for a couple days and they get new features. And that's because of the architecture. Yes?
At which point do you have the discussion of where you're going to control the code, or if you're going to control it, or how you're going to organize the hierarchy of the code?
I'm usually the developer on this, so it's up to me. But we always use SVN, source code control. And the way the code is controlled usually is fairly simple, but we do have a release system for the code because this actually goes out to several laboratories throughout the world, to China, to Israel, where they're doing fab. So they need to make sure they're all using the same version so they can be sure that the results are all the same. So we have a system built into this that actually will call the server and check the current version of the software and make sure that it's running the current version of the software. So we put it as a release, and the systems automatically know that they can be getting that.
Are the targets using runtime or?
We're all using exe runtime. Yeah, they're a compiled code. We don't use LabVIEW in that directly because they're not LabVIEW programmers. They actually, in some cases, the people working on it aren't very skilled or knowledgeable about semiconductor test. They can be, right at a school or something like that, and they don't have a strong understanding of our program. And I'll get into that. It's asking the question, who's your client and who is going to be actually using the product. One of my projects, the client basically wanted anybody who has a high school education to be able to run it. And there's a lot of things like pictures that circle things and say, do this next. And that simplifies it for people. And that goes into, understanding your project. What is it supposed to do? Coming up with a strategy, creating your plan, and then tracking your progress. So I'm kind of hammering on those points because I think that's really the core. I don't know if anybody wants to disagree with me on that. I think that's important. So I'm going to get into flexible design. What is your architecture and how expandable is it? Checking your progress, controlling your spaghetti code, and I say controlling, not eliminating, verifying with the customer, testing frequently in real-world situations. So for OnPoint, it's a pretty complex system. But what I did on the front panel is I defined 3 columns, 1, 2, 3, define, configure, and run. It's pretty straightforward. And people who look at it say, oh, okay, I know that I have to do something around here first, and then something there, and then something there. And I have little checkboxes too. If you've done this step in the past, when you pick your project out, as soon as it loads, it puts checkboxes in the things that need to be done if they're done already. So you can see from the front panel, I can run this now. It's ready to go. And then I can run my manual test or run the actual tests. And that actually simplifies things for the user. We've added to this. This is a couple of years old now, but it's still the exact same format. And process data is off to the side because you don't ever actually have to do that. They've actually stopped using that for the most part. They have a cool new tool that does all kinds of cool processing. So it's pretty easy in that regard. So I encourage everybody to find a hierarchy for your software that says do this first, do this second, do this third, and present that to your users.
I'm just curious why you're using a button with an X on as opposed to the panel close window. And by the way, we have that in many of our BIs as well. And I know what my answer is, but I don't know what your answer is.
I like your question. At the point when I created this, that seemed like a good idea. This was a couple of years ago, and I probably would just use the standard tools now and part of the window to have the X in that. If I was recreating this, and as a designer, I really want to recreate it, trust me. To me, it's ugly now because it doesn't have a lot of cool stuff that I'd like to use. And not using some of the Windows standard built-in stuff to the window makes sense. I didn't know as well how you can control that programmatically to keep them from hitting the X and closing your windows at random points, because that sucks a lot. And I've had problems with that in the past. So, yes?
You may want to redesign this, but looking forward to the GUI presentation. This is amazing. So everybody take a mental as a good example.
And I have a lot more GUI shots in this too. So
Good.
I can talk
Good.
about that. I'm happy.
This teaches the user right out of the box. You don't need a document or even your one-page.
And that's actually one of the things I'm going to hit on is I very strongly believe that you should include documentation in your code, but on your front panel too. Explain to your user how they're supposed to be using what you created, because most of the time I see stuff created by programmers that don't do that. It's every button in the entire program is on one screen, and they're color-coded by pink, orange, and purple, because everybody who uses the program knows what orange means, right? Yeah, and so I hate when I see that. It makes me sad inside. So your core architecture. For this, each sub-VI is entirely self-contained and driven by configuration files, and we heard that earlier. I switched to OOP for my structures because I learned what OOP is and how awesome it is. and how things like a cluster can be turned into OOP and gives you 100 times more control and scales automatically when you change it. Because on my front things, when I'm doing my configuration, I'm going to add things to that need to flow down into my execution stuff. And I really don't want to sit there creating new type depths and having 50 type depths that I have to flow down. If I do it with OOP, I can create new classes and all that fun stuff. And it's still on the same wire, which is awesome. And also you can package that and save that off to a file, and it handles it automatically. And when you add stuff to that class, it adds it to your configuration file in your hard drive. So I don't have to create new import and export routines, which is time consuming and annoying, and then I can create bugs that way. So I suggest looking into OOP, even if you're just going to use it for data. It's pretty awesome.
So are you using the flattened XML or are you using?
Yeah, I think it's fine. So it's really good.
What do you do for trying to load a configuration file that was written with the previous version of the class? The automatic mutation works okay?
Yeah, it's completely automatic. I don't have to change anything.
We broke our top level class yesterday.
Nice.
So
So you broke this ability to read the older classes through the mutation.
we smoked good.
Do you know
So,
how? Or do you know what
I've
happened?
got the code on a branch and the code on a trunk, so we could go look at it.
Yeah.
But
'Cause I think
we
you can
broke
also-
auto backwards mutation yesterday, and I don't know what did it
Okay.
because
That's, we get to nail that one down. And I think, I recall also doing this writing to binary as well, and it was not an issue. So it was either formatted XML, write, or binary. In both cases, it was, I think, I had to double check, but I think it was Ryan Piscini of All Aerospace did the binary version of it.
we're going to and from binary, and it's objects with objects, and I touched some stuff pretty far down in the object hierarchy.
I have broken it once or twice.
Yeah, it's not the first time.
It's
not
great,
impossible.
especially for small and medium sized classes. Fantastic.
But has Stephen laid out and specified, okay, here's where it will break? I mean, do we document that anywhere?
I haven't seen it.
Okay.
I've seen that once before, but I couldn't point to it now.
Okay.
I have broken it, but it's not, compared to doing it any other way, it's 100 times easier.
Right.
Yeah.
I use flattened XML because I can open it in Dreamweaver, and Dreamweaver beautifully formats your XML so you can read it. And binary, not so much. So here's one of the things I wanted to touch on was my job is to take the customer's expertise and turn that into a functional system. The customer doesn't know how to do that. What the customer does is they know their application, how their stuff is supposed to actually work. This is pretty close to what I saw a lot on whiteboards. And then you got your formulas and all kinds of interesting stuff that I have never seen anything like that in LabVIEW. But up there in the corner on this one, at least I stole it, says MATLAB code. Oh, well, we can put MATLAB into LabVIEW, cool. Show me some MATLAB and I can put that in. Or show me how to do it and I can figure out how to do it on the corner there. And that's a lot of what I do. I sit with the client says, here's what this circuit's gonna do and how we wanna measure it. And they'll explain how that works because I am not an EE and I am certainly not an experienced engineer working on parametric testing for the past 20 years, which the guys I'm working with are. And so I don't even try to pretend to be good at what they're doing. I try really hard to understand what they're doing and then translate it. And I'm really upfront with my clients. I'm not, an expert in this. You are. And that's what I go back to on that other slide I talked about is they're bringing me in because I'm good at something. I'm going to own that I'm good at that, but I'm not going to pretend to be something I'm not. And that works really well for me. And it also allows me to do the cool thing that helps a lot sometimes is, I don't know. I really don't know how to do this. Please show me. And once they do that, we both get an understanding. And they know that what I'm doing is correct, which goes a long way, actually. It's recipe driven and optimized. So when we create our recipes, we create a list of the tests we want to do, the generator settings, the limits, the voltage, all of that. This is an example of something I don't think is pretty, but it does work. But each of these is a set of tests that we're going to do. We can sort them, and then we can optimize them. Because this is not where these tests run. We load these into our execution program. And when I run these tests, I'm breaking them into 100 little things that it has to do for each test. And over the time I've been working on LabVIEW, I've figured out new ways to do things, and I can implement that at that phase. So I consider compiling your code. And you can run your optimizations in compile time. All my hardware is abstracted and has GUI controls. So my hardware, I have an interface in my software that says open, or write this to it or read this from it. And what it means is all my interfaces can be that, because that's pretty simple. And also on my graphic user interfaces, I can put on images. Really easy to drop an image into LabVIEW. And so much more powerful when you have a little image that says what it's doing instead of just having text over it. Because new users don't really know what I mean by transition. But if they see a little graph or a duty cycle graph, well, that's what duty cycle is. Cool, okay. So I want that. And you look at that column you came in. And it clarifies things. Using imagery and using simple things like that go a long way. Green, it's dark, it's bright, but instead of using black and white, it's green. It means it's on. It makes more sense to users. Be careful with color. In other countries, colors do not mean the same things they do here.
Do you have an
board and
example?
pins. Yes.
Do you have an example of colors
let's see.
that bite you?
In America, black is kind of the death color. I understand in Asia, it's the red, purple is the death color. There's a lot of stuff like that. Red and green generally mean the same thing between countries. But if you look up on Google, you can find lots of examples on per country basis of what different colors mean. Colors we find calming aren't necessarily calming in other countries. So it has significance. If you're doing things for other countries, keep that in mind. Make sure you just do a little bit of research on that. So board and pins. What I did here is this is actually, if you look at the board we actually hook up, this is pretty much exactly what it looks like. And we're calling out the numbers for force and sense. And then on our pin description here, we're calling out those numbers and putting in what those names of those pins are, what they're actually functioning as. What this does is later on in the program, I can say I want to see the ground pin versus the reset pin. And they don't have to know anything about the channels in the box or how that works. It's actually pretty complex because we have several boxes switched together that chain through each other. So we have a software subroutine that does that, and the client has no idea, and the user has no idea that it's doing that. They just know that they put in a ground pin and they can get to it. And that's the kind of abstracting that I like to think about when I'm writing programs. They never asked for this. They didn't say, oh, well, we wish you did. They actually asked for, like, give me a spreadsheet that I can put the pins into. No, let's do it this way. This is better. Measurement architecture. Test systems items are configurable and totally abstracted, as I mentioned before. This is actually how you configure the test recipe, which is each individual test. You can see that TSU in the corner, which is an image. Back to what I showed you earlier. The image makes it easier for people to understand what they're working with. One input to many outputs, one output to many, or one input to one output. You can pick how you want it to work. Then you go into your configuration and tell it how the specific test is going to work. You can even give it a different kind of read on the end, so you can kind of create your own test. What your limits are, what your percentages are for those A and B points, and then what your triggers are. So a couple of you have used parametric testing in the past before. What I try to do is make this so you don't have to really know how that works exactly. You can have a general idea of what it's doing and set your tests up. And that also makes it easy to go back and configure the tests. And secretly, I didn't understand parametric testing as well as I should have before I started working on this project. And doing these sort of things with graphs and pictures helped me as a developer understand what I was doing, and it makes it so much easier to debug the test. Because I couldn't always go to the client and say, oh, this part's not working, and I have no idea why. If I understood what I was doing, and I could see it with visual clues and some information like this, it helped me do that. So it was useful in that regard as well. So OnPoint is built with a prioritized queued state machine. So I mentioned having little chunks. Having the ability to say, these chunks are way more important, do them now. It's very useful. And saying stuff is going to happen at the end, but I don't care when that happens, is also useful. Individual hardware access points are states. I mentioned that already. They're created by arranging hardware read-write configure states and processing states. And all of that works well, but it's also easier to debug. On the front panel, hidden in a place that I only see on the administrator when I'm running it as an administrator, I can see each state as it's running. It actually shows me the state name. And it shows me how long it took to run that state. And I can actually log that with a button, turn on logging, and it saves that. Now, how many people have had memory leaks ever in their code, right? Okay, when I'm running the code the 50th time I run it, and I start seeing the state taking much longer, I don't even have to see there's a memory leak. I can see the time. It's used to take 2 milliseconds, now it's taking 50, or it's taking 500. before I really start to see the code slowing down visually, I mean, I don't see 50 to 100 change in 1 second. It's just a slightly bit slower. But across 100 or 1,000 tests, that's a huge amount of time. And I want to optimize. So I can actually look at how long these things are taking and find out where I can optimize best. And trim time out of the testing. And that actually goes a long way. I suggest trying that. Even if it's something you can turn on and off, it's a good idea. So the core architecture, I mentioned some of how this works. This is actually a more complex example, but it's the same core idea. Also, this is where each of these information points come from, and you can see they're clustered. The overall stuff is the test list. The test recipe is the general, how they work. And then specific things like the generator presets and board and pins are a subset of that. So I tried to, at the very beginning of the project, architect it so it's simple, even though it's really a very complex project, taking those bites of the elephant. Over here, this is VIH test. It is a sweep test. It used to be done by hooking up to the board, changing the power on it, and watching the output to see at what point your test fails. If you give it too much power, your part's going to fail. If you give it too little power, the part's going to stop signaling correctly. At what exact point does that happen? Problem is that you can't just make a test that does that. You don't know when that's going to happen. So I may have to run 50 questions against it. What's the value? What's the value? What's the value? I may have to make 100, maybe not 800. What this does is it actually dynamically creates states as it's running. It goes to an evaluation state and says, oh, I'm not there yet. Give me another batch of tests. It goes and hits the, increase the value of power, run the test. Increase the value of power, run the test. And it'll do that as many times as it needs to with the threshold for failure if it just goes too far. And by doing that, we can create tests that I never planned on doing because we can use the architecture to our advantage. Using small chunks in our architecture lets us create states that create more states. It's flexible, it's very powerful, and I love it. Automating testing, minutes or seconds per test, better, faster, time to market goes down. And it's expandable to include future projects, future testing methods, future communication methods, and more. We added I2C testing to this architecture about a year ago, and we did not have plans to include I2C testing. It went in fine. It was just a couple extra states, a couple extra processing modes, and it works like a champ.
I'm going to toss up
Yeah.
what I'd call a big glaring missing item, and that's consistency in that previous slide. Automated testing gets you all kinds of consistency.
And actually, I do mention that is the way I see testing consistency is the client occasionally came up with, I wish, can't we change this thing as it's running? No. When you run the automated test, everything will always be the same because your results always need to be the same. Your client, he's providing this data to somebody else in the company, that's his client. If his client sees variability in the data and finds out it's because he can tweak things when he's testing, oh, people believe your data no longer, and that's bad. We want people to trust that data like it's rock solid. So checking versus the progress plan. This flowchart on the right here, this exact same flowchart I can still use today. Everything in the software works the same way, and that's from years ago. The config utility, the test setup, the automated testing, the data reduction. Sure, it's kind of simple, but it's exactly the way the system still works, and that's pretty impressive. I just found this when I was preparing for this presentation. I was like, crap, that's awesome. That the original structure I came up with still is valid. We've actually redesigned the software once. A couple of years in, Ray, who was originally working with me on this, left the company, and Dwayne came over. And when we were looking at it, he's saying, oh, here's a list of 200 things we want to add to the software. Oh God, no, it's not going to support this because I didn't structure it that way. What I did was I went back and I changed the way the state machine works, and I rebuilt that part of the engine. And as you know, you always find the new shiny state machine or new system that you love. I found one that really took into account all the things that I learned in the first one and rebuilt the system. He was really great about it and said, okay, you're going to rebuild this, it's great. This is your one time, you don't get to rebuild it again. So I had to take a lot of concern and thought into the system before I did that. But even so, it's still the same basic architecture. Advanced systems, features in it. I created an entire scope inside of it that stripes. And the advantages of that is you can pick the pin you want to pick. So you say, I want the ground pin, I want this pin. It'll actually switch the mux dynamically to any pins in the system you want and include them on the graph. You can do 50 pins on here even though we only have one scope. It'll automatically do that in comparison when you have the offsets so you can move them. And it's very much like a regular scope, except it's built within the system and you can stop in the middle of the test and run your scope and see what's going on with those parts. It makes it so much easier to diagnose when you've set up the test problem. You know, because if you just have your voltage off slightly, it can screw your test up and part won't switch. You can actually look at that. I2C, I mentioned that. We actually have where you can look at your I2C logic directly, and it will show you what's going on. And that's fun. It'll actually, on the new software, will actually tell you what these mean. Like, it'll take this chunk of 8 notes and tell you, oh, that's E, or whatever it is. So you can actually read your I2C. And this is actually a utility we got from NI to configure and set up your I2C. I adapted that, modified it, and put it into the code. So you can change your I2C settings in your setup, run them, test them, and then put them in your automated code. And it works flawlessly now. It's a lot of fun. It was kind of a pain to do, but it was worth it. Spaghetti monster. Everybody encounters this, right? So we had it happen where tomorrow, the VP of this division is coming down to look at your code. We want to show executing code that looks good and works. Great, I'm going to make sure I test today. So I was testing. Halfway through the day, I found a flaw that I knew for a fact was going to show up when the VP was watching the code, and it would break, and the system would stop working at that point. Well, I suddenly stopped caring how pretty my code was. I made that code work, and it came out looking like spaghetti because I had all kinds of bypasses and fun things in there. And what I did is I added, spaghetti code as a note right next to that code in that sub VI. Well, it's in a state machine, so I know I was working on this sort of part of it. But I also putting the tags in. You can actually just do a search, and it'll pop up a list of all your tags and say I'm spaghetti. And you can go back and find those the next day after the VP leaves and fix all that code. That also works for code reviews. You can put that in and say, look for spaghetti tags. Well, if you're tagging your spaghetti code, it's a little more forgivable, I think. Yes.
What are you using to tag? Are you just using block diagram comments or the new?
Yeah, not the new stuff because it wasn't out when I was doing this.
There's new stuff. Who knows about it?
Yeah.
Yeah, it's
Isn't
good.
that great?
Give us,
It's
give
cool.
us a 10
I'm glad they
second
added
bio
that.
for it because it's awesome.
Yeah.
What is it? What's it called?
2013 has hashtags.
Yeah.
You can say hash spaghetti, and then there's what they call it a
Bookmark manager.
bookmark manager that shows you all your hashtags, and you can sort them by filter them and that kind of stuff.
Yeah.
In your
That would be
project,
perfect for
yeah,
us.
that's the whole process.
So how many people here use a system for handling their spaghetti code? Ha! I thought so. Cool. Okay. I suggest it. You know what? You admit that you have it because we all do it at some point. And it's fine. And then go back and fix it so you can actually show your code to people without it. Quality customer feedback. So over here, this vector list is a way you configure it so you can actually show the customer how they're setting up their hardware. I didn't think about this. The customer suggested some sort of utility to do that. We talked about how to get there. And clear design comes from clear customer communication. Understand what they want, propose some solutions, and if they like something, go with that. Sometimes programmers can tend to, and I do this, get an idea and go, this is so awesome, I'm totally doing this. And then you do it, and the customer goes, what the heck's this? I have no idea how to use this. And that's because there was some breakdown in communication. What you made isn't exactly what they want, or they don't understand why you made it that way. So, testing. Assume nothing works until you've tested in real world conditions. I like simulating code, but I don't like simulating code as much as I like hooking up to an actual part and testing it. We were talking about edge cases. There's a case on a part where as you reduce on a part, you have binary. It's either on or it's off. It's a high state, it's a low state. Well, all parts are not actually digital. They're all analog. So there's a point where you're switching from high to low, that it's not high or low, it's a slight angle to it. And if you sample it at 20 gigahertz or whatever, you'll see that it's a nice curved line that kind of drops down. If you're sampling and you're doing a, twist the knob to find a certain point, it's possible to twist the knob and find that point exactly halfway on that curve. And noise determines if it's a 1 or a 0. So you keep testing that point, and it's on and off, it's on, it's off, it's on, and then off. Well, my sweet code to do that found that point and was like, oh, accuracy, let's find out exactly what point this is. And it got confused, and it continually died. And that was because we were running into a real phenomenon, and I was measuring something that I didn't need to measure. So I talked to the client, and the client's like, let me show you a theory of operation and explain what was happening to me. And I realized that we need to add a module that detects this and stops it and says, okay, this is as accurate as I can be. And it sped up testing because it didn't need to keep testing after that point. Build-in time for testing, handle your errors gracefully. There's no quality control without testing. It is quality control. You don't have a stable product until you tested it to be stable. And the customers may try to hurry you on testing because of tight deadlines. How many people have ever had somebody say, okay, this is good enough, let's do it. Right? Okay, we're almost out of time here. We got 2 more days left. We need to just be done with this now. Like, no, this is quality control. We must do testing. We're building the time in testing in front of the system. It's 10 days for development, 3 days for testing, and it's there for a reason, because we need it. And depending on where you are in your code and what kind of code breaks, it can take a long time to fix your bugs, or even find them. So when you're planning, plan in that testing time, and don't allow people to take away your testing time. Defend that. Because it's not just you, it's success. It jeopardizes success if you don't have testing. So understand your project, develop your strategy, create a plan, track your progress. And then when you're executing, make sure you have flexible, expandable architecture. I rebuilt my code because I wanted to create that flexibility, that expandability to it. Check your progress against the plan to make sure you're not adding features you don't need to add, and you're not doing things in weird ways that confuses your customer. And then verify that with the customer, make sure they're happy. And then test it frequently in real-world situations. So I have some references and resources. I wanted to ask some, if any of you guys have any questions about this, or you run into problems that I could help with in some way. Anybody on that?
I know with meeting with customers and trying to get requirements locked down, they don't want to take time to explain them to you. It's good to throw out some NRE money, some seed money, where they aren't committed to you. If you do a chunk of requirement work, they can use any customer, any vendor they want. They're not committed to you if you're consulting for them. So it's good to kind of get the project going off, like that, because if they can't send out the requirements, your project's just stuck.
Yeah, it's getting good requirements on the front of the system design is really, really important. Even some confusion and assumptions customers make sometimes can really bite you in the butt. I had a customer who came and said we wanted a system to test inputs to outputs in our system, but there's 500 of them. Okay, well I can do that. You create a system that makes input 1 connect to output 1 and test that line. Well, I found out later what they meant was input 1 can connect to any of the 500. So they forgot the word any.
You can't quote the project if you don't have good ones. So
right, yeah. Well, they came back and said, no, we need any. And I came back and I said, okay, your $20,000 project is $250,000 because we went from a multiplexer to a matrix. And they're a lot more expensive. And it's going to take, instead of 1 rack of instruments, it's going to take 4 racks of instruments. And that makes a whole world of difference just for 3 letters. So you can really get bit. And you really want to clarify with the customer. That's where my diagrams come in. Draw a diagram of how the system works and explain that diagram.